Hey Opties! Today we're going to be doing a linear equations review, talking about the three types of formulas we've used for linear equations and including our parallel and perpendicular slopes. So first off, let's look at our red equation. This is our point slope, and we have some sliders here, and we've made our y1, which is our y-coordinate of our point, 0, our slope 2, and our x-coordinate 1. So we should have the point 1, 0 on our line, and let's check that that's true, and it is right here. That's our x-intercept. So let's take a look at our blue line. That's our y equals mx plus b. That's our slope intercept, where m is the slope and b is the y-intercept. So we have b as 2, which means that should be our y-intercept, and it is. And since m is the same letter as our m for our point slope formula above, then our m is also 2, just like it is for the red. And we can tell by looking that they're parallel, right? Remember, parallel lines are lines that never intersect. They have the same tilt, and tilt is slope, so they have the same slope. For point slope and slope intercept, it's m for both of those for the slope. Finally, we have our standard form, our green line here in the middle, and our a is -2, which is the coefficient of x, our b is 1, and our c is 0. Remember that our slope for any standard form can be found by solving that equation for y and then looking to see what the coefficient of x is, and that's because it's a conversion to the slope intercept form. But always, whenever you do solve a standard form for y, it always ends up being -a divided by b for your slope. So if we take -a, that's going to be +2, so negative times -2, of course, is a positive. And then we divided it by 1, and we got a +2. And notice that's the slope of our other two lines, and they're parallel. Let's practice guessing and checking with Desmos in solving a problem where we're supposed to write our answer in slope-intercept form. So it says, what is the equation of a line containing the point 4, -2, and also parallel to the line represented by the equation y equals 3x plus 1? And it technically doesn't ask us to write it in slope-intercept form, but let's work it as if it does. So we want to go through the point 4, -2, so we can start by plotting that. And we see that right here, and click label, and it shows that to us. And we want to go parallel to the equation 3x plus 1. So we can start by just putting a slope of 3, and then we can guess and check for our y-intercept. Y equals 3x, so that's parallel to the given equation because it has the same slope. And we know we want it to go kind of to the right, but if you go to the right, you can also think about that as going down. So let's just start subtracting numbers. So maybe -2. That's not enough, so let's do -5. Still not enough, so maybe -12. We need a little bit more. 13, no. 14 looks good. Now, let's be sure, like if we zoom in, we can still see that it looks like our line is intersecting that point, but let's double check for sure. So we can go to our gear and click table, and then we can type in a 4, and if we get a -2, that means that point really is on our line. And we do. So that is the equation that's parallel to the given line through that point, and it is in slope-intercept form, that y equals mx plus b. If you had a multiple choice question like this, then you could use your answer choices and to see which one is parallel and also goes through that point, and you wouldn't have to find it from scratch. Let's look at a question where we are writing our final answer in point slope form, and we're actually given our equation in point slope form as well. So we want to go through the point 5, 1 and find that line that's perpendicular to this given line. And it's y plus 3 equals -3/2 times the quantity of x minus 6. So let's start by plotting our point, because we want to be able to visualize if our line goes through the point, because that's one of our requirements. And the other one is to have the proper intersection or non-intersection. So intersection of 90 degrees, which would be perpendicular. So we'll do our 5, 1, And we'll go ahead and label that. We want to have a perpendicular slope, and what's great about point slope is that you can use a point to write your equation. So there is no guess and checking for like our y-intercept like we did for our slope-intercept. We can literally use the point given to us in our formula, and that makes it exact already. So that's why I really love point slope. So we're going to do y minus the y value, which is 1, and it's going to equal the perpendicular slope, which the opposite reciprocal of -3/2 is positive 2/3. So we've got 2/3. Arrow out of your denominator to put your x on the outside, or in your numerator, that's fine too. And we do need x in our parentheses. And then we're going to subtract our x value, which is 5. And we're done. Point slope is really straightforward. Again, you could always use your answer choices to guess and check to make sure it does go through that point. And if you're trying to guess and check, you would want to graph your original line. So let's do that. Y plus 3 equals -3/2 times the quantity of x minus 6. Okay, so the reason you need to plot your original line or graph your original line is so you can check to see if it looks like it's parallel or if it looks like it's perpendicular based on what you want to find. So we can see that they do look perpendicular in case you were kind of like iffy if you did the slope correctly. And if you do want to double check to make sure your point's on there, it actually does not let us do a table for a point slope form. But if you changed it to be just solve for y by putting a +1 on the other end, then you can do that. And we check that 5, 1 is a point, and it is, so we're good there. Finally, let's do a standard form problem. So we have the point to -1 to -1. We'll label it. And we want to go perpendicular to the given line. So let's go ahead and plot the given line so we can visualize that. Instead of just going off like algebraically finding the perpendicular slope, we can use our visual to double check. So now that we have our point and our line, let's go about finding the line that's perpendicular to this given line through that point. So this is standard form. So our perpendicular slope is going to be b divided by a. Okay, so that's the slope of the line we want. So we can simply do the b over a of our given line to find our perpendicular slope, but we have to rework that to be into our original. So I'm going to start by writing this in standard form, even though the question does ask for slope-intercept form as our final answer. But let's start by doing that. So we want our slope to be 4 over -12, which we know is -1/3. So that means we want -a to be on our x, so it's going to be +1x, and then a 3 for our b. And that we're just going to guess and check our c. Let's just put 6. Okay. So let's say we increased our 6 to be 9. So it's going up. We don't want it to go up. We want it to go down. So let's do 3. Not enough. Let's do 0. Still not enough. Maybe -1. That looks pretty good. So notice we can't make this a table because it's not solved for y. But let's solve it for y because we need to do that for our question anyway for putting it in slope-intercept. So y will equal, or let's start in steps. Let's do 3y equals -1, and I'm writing it as if I'm subtracting x from both sides. So it'll be -x. And then if I divided both sides by 3, that 3 would go away, and there would be a 3 is the denominator on all of this. So a -1/3, and then a 3 for the denominator of x as well. So there we go. There's our slope-intercept. It's almost slope-intercept. We really need to put our x in front. So let's rewrite this. So y is equal to, and their coefficient of x is really our -1/3. So -1/3 x. And then we have the -1/3 on the end right here. So -1/3. Awesome. Now let's double check. Gear, table, and 2, -1. It is there. Awesome. All right, Opties, that's it for guessing and checking with Desmos for our linear equation forms, including parallel and perpendicular. See you next time.